You know, I know some of you are regulars at Immersed each year, and I'm hoping you're seeing a difference is that it's not just about immersive technology. There's other parts of the ecosystem that are very important that drive this future computing world. So we're running a bit late, but I think we should get our keynote in before lunch. Derek Orr. Is Derek in the room? Okay. See, normally they catch me from behind. You know, I'm just going to share, to introduce Derek, the first time I met him was at CES. And he had a big exhibit. There were drones, there were virtual reality devices. Come here, Derek. It's right over here. And I'm like, what do you do? Well, I work for NIST. And what's NIST? It's the National Institute of Standards and Technology. We run the atomic clock, and from there I was sold. So let's welcome Derek to the stage. Give him a big round of applause.
Thank you very much. I appreciate it. Normally it's tough to be the person standing in front of lunch, in between lunch. I'm now standing on top of lunch. So I apologize for that. My name is Derek Orr. I'm the Chief of the Public Safety Communications Research Division at NIST and the U.S. Department of Commerce. If you're not familiar with NIST, it is the United States Metrology Laboratory. So it sets the weights and measures for the United States, the kilogram, the nation's time. We even have NIST peanut butter, in which people use to calibrate their machines to tell them what is in peanut butter. So NIST is the Weights and Measures Institute, and it is important for trade inside the United States as well as outside the United States with partners. So as part of NIST, I work within the Communications Technology Laboratory and am the chief of the Public Safety Communications Research Lab. My division's focus is strictly on public safety, as you can probably tell from the name. So we really focus on, in our case, in the United States, state and local public safety, police, fire, and EMS, and their ability to communicate on a daily basis. We're not focused on just the end of the world event. We're not just focused, and the next slide will kind of look like the end of the world event, but that's not what we're necessarily focused on. We are focused on the traffic stop. We're focused on the crash in an intersection. Every single event for public safety is an emergency. There's no non-emergency typically. They're called out for emergencies, and it's everything from a dog attacking the mailman to what the next slide shows and how we got here, which was really 9/11 in the United States. So this is one of those events and it was an event that really changed people's perspective on the capabilities of public safety, and not just in the United States. This was worldwide, and the fact that at that time you had 343 firefighters lose their lives, 23 police officers lose their lives. And a large part of that was because there was a communications issue in which the firefighters couldn't communicate with the police officers. Police officers got the communications, they were able to get out. Many of the firefighters didn't get that same communications, and they weren't able to get out. That seems absolutely insane. Even though that was in 2001, when we weren't in the iPhone age yet, I was still able to call somebody on a different carrier network if I wanted to. And the idea that our responders couldn't show up on scene and talk to each other was crazy. At that time, I worked in the United States Senate, and I was actually focused on accounts dedicated to state and local law enforcement. And after 9/11, my job was to start to work with the state and locals across the United States and look at the interoperability issues that created the situation that occurred at 9/11. And so we started to pump billions of dollars in the United States into new systems that would be purchased by state and locals so that they wouldn't have the same situation again. That issue became my passion. So I left the United States Senate and I went to NIST in 2002, and I've been there ever since in the same position for 16 years, the head of this division, and working to solve public safety's communications issues. Originally, when I first got there, our issue was, how do we make sure that when somebody shows up with that Motorola radio, that they can talk to somebody that shows up with a Harris radio? That was the problem. That was one of the problems. There were numerous problems. Part of the problem was public safety didn't even talk to each other. Fire didn't talk to police didn't talk to EMS, even within the same city. Oftentimes they owned their own radio systems within the same city. Oftentimes those radio systems weren't even the same manufacturers within the same city. And oftentimes those radio systems weren't on the same spectrum within the same city. So there were all kinds of issues that led to interoperability problems. And our job was to try to solve the standards issues. Our job was to try to solve some of the technology issues in land mobile radio. That is what those devices are called, land mobile radio. That is still the primary method of communications for public safety, those radios. That is what you see them use across the world, and that is what they will be probably using for the next 10 to 15 years for their primary voice communications, and voice communications is their primary means of responding. Just a note, we're used to going to the store, buying a new phone, getting an iPhone or an Android device, and spending maybe out of pocket a few $100s. If you wanted to buy it outright, you're spending about $800. These radios are about, at minimum, $6,000 to $7,000, and they can get as expensive as $12,000. And you've got local fire departments, many of them volunteer, having to raise money to buy a $7,000, $8,000 device that better last for 20 years, because that's how long they have to make that money stretch. And therefore, now you have a situation where public safety is never on the cutting edge, and instead using 20-year-old technology because they can only invest in it once every 10, 15 years, and it's so expensive. Something has happened in the last, I would say, probably 8 years, which is because of 9/11, because of the focus on public safety communications and their need to go to the into the future, which is what this whole thing is about, there was a commission, and that commission said public safety needs to go from land mobile radio into a nationwide broadband system. They need to be able to have their own single network so that a police officer from New York City could respond to an event in LA, and they could talk across the entire nation and show up and not worry about whether or not they were on a different radio system. In 2012, that actually occurred. In 2012, the US Congress passed legislation that created a nationwide public safety broadband network for fire, police, and EMS across the United States. It provided them $7 billion and provided them 20 megahertz of spectrum, which, to put that in perspective, Verizon in the United States has 20 megahertz of spectrum for about 100 million customers. AT&T in the United States has about the same amount of spectrum for 100 million customers. There's about 5 million, if you stretch to the maximum extent possible, about 5 million public safety users. So they got as much spectrum as a Verizon and an AT&T. And they were given that spectrum to create a nationwide network. We were also, as NIST, to support that evolution for public safety, provided $300 million to do R&D into public safety's future communications capabilities. And so that, even though it doesn't compare to $7 billion, that is the most money ever injected into public safety at state and local levels, R&D for their communications capabilities. So it really was a singular event. It came with some special requirements, which is the money goes away in 2022. So we don't have a lot of time to do this. We have to act fast and we have to be aggressive. So that is what we're doing. And so we're no longer focused on land mobile radio. We're focused on the future of public safety. So when you walk into our lab now, land mobile radios are kind of on the shelf. We use them every once in a while to figure out how they're going to work with the next generation of systems. But we have VR in our labs. We have AR in our labs. We have LiDAR backpacks in our labs, looking at location-based services and mapping buildings. Our laboratory now looks very, very different than it did 10 years ago when we were focused on 2 different walkie-talkies being able to communicate with one another. So what are we focused on now? Not much. So as that's coming up, around 2013, after the legislation passed, we started doing a series of technology roadmaps to figure out, we didn't want to waste this money. It was a one-shot deal, and we didn't want to chase bright, shiny objects, and we wanted to make sure we focused on the most important things that would transform public safety communications. So we started getting industry together with public safety and academia, and doing technology roadmap. And at some point, I'm going to be able to talk to you about the focus of what came out of those discussions, and I can talk to you about it without having a slide. I've done this a billion times. But so we sat down with industry, academia, and public safety and said, okay, what are the 5 things that would truly transform public safety in the future that we should spend this money on? And we're not looking at anything else. And so it took us about 3 years to get through that entire process and develop the roadmaps. And our imagination shouldn't be at work yet. It should be back several slides. So out of that really came 5 key areas that we're focused on. And really, listening to everybody talk this morning, it's all about what you're already talking about. It really is. The future of public safety is really about what you're talking about, leveraging the capabilities that are already being discussed. But public safety comes with some pretty unique requirements that aren't the same requirements as a gamer or a commercial customer, right? So, the 5 areas were, 1, for a period of time, they're going to have this next generation, the first generation of their next generation device is going to look like a smartphone. But it's the first time they're going to have a smartphone. No, we're still back. Can I go back? No. So the first generation is going to be a smartphone. It's just probably going to have some extra features, and it's probably going to be mil-spec so they can drop it and it can get wet. But it's going to be a smartphone, and they're still going to have that land mobile radio on their head. And somebody's going to show up on a scene, and they're just going to have that smartphone. And somebody else is going to show up on a scene, and they're just going to have their land mobile radio. And those 2 systems have to talk. So that's one of the areas we have to deal with. We have to have these 2 systems show up on scene and be able to communicate. The other is those land mobile radios do things that our smartphones don't do. And even though they look antiquated and they look old and they look like World War II technology, they do things that we can't do on our smartphones that are critical to public safety. Can I go forward now? Okay. Okay, I'm going to start over because you don't really want to eat. Just getting past this slide, that'd be great. So we have to get those critical features off of those land mobile radios onto our smartphone devices. One of which is push to talk, right? They have to be able to hit a button on the side of that radio and they talk. That sounds so antiquated. It is so important because when they hit that button, nobody can talk over them. And when they hit that button and say, don't shoot, you don't want anybody talking over the word don't, or that's a really bad day for somebody on the scene. So they have to have push to talk. That is the way their operations work. And they're not looking to get rid of that anytime in the future. The other is one-to-many communications. They talk not 1-to-1, they talk 1-to-50, 1-to-100. So when public safety is talking, they're talking to many people at once, and they rarely do single individual calls. And then the third is that they have to be able to do direct mode communications. So those devices that were up there, if all the infrastructure is gone, they can still talk device to device. They don't need a tower. They use a tower if it's there, and they get better capabilities with the tower, but without the tower, they can still have, when there's firefighters in Colorado responding to a scene, a rural fire in the middle of nowhere, they can talk with 100 people around just from device to device, and they don't have any infrastructure in place. That's incredibly important for them to be able to do their job. So, now we got a problem here, because I've got to go past the slide, okay? And we're going to stick again. I'm not touching anything. All right, so those are the 2 voice capabilities. But then,
don't you wish the slides worked as well as your radio?
I do. I would pay $12,000 for that. So then we asked them. Those seem grounded in today's technology, right? That was what I just talked about. But then we asked them, and that stuff has to get done. But then we asked them to push forward. There you go. You can just stay right there. That's perfect. We asked them to push forward and think of areas that would truly transform public safety capabilities in the next 5 to 10 years, 10 to 15 years, maybe. And the 3 areas that they focused on for us, one was enhanced location-based services, the ability to track personnel and assets inside of a building. Very, very difficult problem. The next was enhanced analytics, AI, whatever you want to call it. But the ability for all this data that's now going to be available to them, no longer just voice data. Now you're talking about the ability to access all of the databases, social media feeds, all at once, and potentially make use of that data to have a better response to an event. That takes some pretty smart back-end analytics to be going on. That's some of what we are focused on. The third, which really dovetails into today's discussion, but I'm not sure that not all of them do, is the fact that enhanced user interfaces have to be developed for public safety. When they get that smartphone, that first generation of that device, they're still going to be asked to swipe. They're going to be asked to enter in a 15-digit security code, and they're going to interact with it like we interact with our devices. Our devices were built for commercial customers. Our devices were not built for a firefighter who enters a building. And you tell that firefighter, hey, this device has a great map on it. You can use it when you get in the building to track where you are and see where you're. They can't see their hand in front of their face. They have gloves on. They can't interact with the device. So we have to help develop interfaces that were actually developed with their operational needs in mind. So one of our major lanes right now is focused on what do those future interfaces look like for public safety. And we're talking heads-up displays, we're talking augmented reality, we're talking haptics, all of the, I've heard the words over and over and over this morning. We're talking about audio cues or voice commands. So we really are focused right now, one of our major areas is focused on how do we get to that next generation user interface. And public safety is kind of ready for it. Public safety is a tough crowd, right? They can't be the guinea pigs because their lives are on the line or somebody else's lives are on the line. So they're not going to go out for anything unless they trust it 100%. They would rather stick with those radios for another 100 years instead of going and showing up on a scene and actually having something go wrong because the technology didn't work the way they expected and it wasn't ready for prime time. So you have to prove it to them. You have to give them a confidence level that shows them that they can depend on it as much as they depend on their current operational capabilities. So to ground ourselves and where we're coming from and where we want to go, I wanted to really level set people's expectations of what public safety looks like and how they operate. This is a scene from RoboCop, and he's driving down the street, and he gets all this information, and he's driving, and it starts to highlight, potential suspects, and it highlights objects, and this is kind of what, some people might think that public safety has that kind of capability as they're driving around, in reality, and they're communicating, they're getting all this information. In reality, this is a very, very common setup for inside of a squad car for a police officer. You've got, handheld mic, you've got another handheld mic if you want to talk over the loudspeaker, you have to open up that laptop and type on it if you want to access any of the databases. That is in reality, it's probably not a very common setup because they probably have 2 or 3 different radio systems in that car because they don't know where they're going to show up that day and they have to make sure they have the right radio for whoever they're supposed to talk to. So they really will have like 3, 4, I've seen cars with 7 to 8 handsets in it. Different handsets, so they would have to make sure they had the right one when they showed up. So that is the current environment for public safety. 3D mapping. My kids watch Hawaii Five-0, and I walked in one day, and they were all around this smart table, and they were bringing in information, and they're swiping people's pictures around and throwing, digitally tossing them off the table. And I asked my kids, what are they doing? And they said, that's how they're planning, the next place they're going. And I started laughing. I was like, you got to be kidding. That's not how it works for public safety. But that's how people think it works for public safety. And this is how people think it might look like for them to sit around and use technology to allow them to figure out where people are inside the building. And in reality, that's probably best case scenario, which is what we have in Google Maps, is an overview of a building and probably no blueprints of what's inside that building. People think, hey, I just talk out loud and I say, hey, let me talk to Joe. And then all of a sudden I can talk to Joe and I'm talking on the group that I need to talk to. That's not how it works, right? They have to hold the radio up to their face even when they're in the middle of a fire, when they've got their masks on. Those masks have vibrating reeds. When the oxygen gets low, the reed goes off. It sounds like you're in the middle of a rock concert, but it tells them they're almost out of air and they're still having to talk over that. So this is the world that they live in. It is not Star Trekian. It is not clean, and it is not easy. Command centers. We see all these movies and all these films, and they're in this room with glass and video feeds all over the place. The video feeds are bringing in information from across the city. That is what command center. I am not joking. That is what command center. I've seen multi-million-dollar command center. I've seen multi-million-dollar industry giants with command centers that look like that, right? This is a very common command center for public safety. And I would say this is a high-tech one because I think that's one of those boards you can write on. So that is probably like state-of-the-art command center. And then this is the example, in my opinion, the example of the future of user interfaces is obviously Minority Report still stands as an incredible example of the future, even though it's 2002. And remember that scene where he's sitting there and he's planning what they're going to do when they go out to find one of the killers or one of the future potential murderers, and so he's got all this information accessible to him so easily. And in reality, it's probably something like that. In the back of a squad car, a bunch of paper, a radio, and working it out. And so this is public safety today. And we just need to kind of ground ourselves that this is where they're coming from, and we need to get them into the future. Our lives depend on them. They help us when we're in trouble. And so it behooves all of us to help them leapfrog into the future. So our job as NIST is to pull that future forward for them. To use this money that we have for a very short period of time to try to inject funds through our research in our laboratories and externally through grants and prize challenges to try to draw those capabilities forward so they have access to those capabilities sooner than they would otherwise. And just to give you an idea, for us to be successful, we have to be able to outreach to people like you because we're not doing this on our own. There's no way. I work for the government. I can't spend $300 million in 5 years, respectfully, right? I could blow it, but I'm not going to. So the only way we succeed is by doing this with the help of industry and academia and entrepreneurs out there that want to help public safety achieve this goal. And the only way we can do that is to get people who have never thought about public safety's problems before to think about them and to realize that the same things that you're working on for gaming, the same things you're working on for for whatever the application you're using, it may actually help public safety. If we can get you involved in helping them do their job better, then we win. So one of our first prize challenges that we did, and this is a prize challenge when I'm talking like SpaceX and the ones that DARPA and NASA use, so that we'll say we have this goal, and the first person to hit that goal will get $1 million. So that's how we're using some of this money, is we're actually throwing prize challenge money out there for people to hit these goals. The first one we did was we want a video that displays to people the future that we can envision for public safety, so that somebody who's never thought about it before could get excited and understand what we're trying to do. So what I'm going to play for you real quick is the prize challenge winner. They're out of LA. We had Emmy Award winners trying to do this. We had a lot of excitement around this. These are the ones that won. This is one of the videos. They actually gave us 7, but this is the overview video.
America's first responders need your help.
Damage from the earthquake is extensive, and the difficult evacuation effort is still underway.
To tame the chaos and crisis, they need a secure mobile network. This new technology provides a quick, secure authentication for all response teams on site, allowing first responders to communicate and share data across departments and monitor everything that happens on scene. Rescue workers need your help creating a way to communicate reliably and securely, even when they are off-network. With robust and adaptive communication systems, first responders are always connected. They need real-time 3D mapping and positioning technology for search and rescue operations, so that no matter where disaster strikes, first responders will always know their way around. When vision is impaired and the path is obstructed, our first responders need technology to guide them safely. With enhanced user interfaces and heads-up displays, the path ahead is always clear. They need help developing a system that will revolutionize the triage process. They need a system that can diagnose conditions in real time and prioritize resources. But they need you to get there. Your imagination, your innovation, your idea, it can make all the difference and help save lives.
So amazingly, by doing that through a prize challenge, that video cost us, that and 6 more, cost us $100,000. So, because they did it we just said whoever wins gets $100,000, and all these people came out of the woodwork, and that won. So that probably, if I would have procured that, that would have cost me $1 million, probably more easily, and we got it for $100,000 through that process. So it's pretty neat. So in the user interface area, one of the things we're doing is, and one of the challenges in developing enhanced user interfaces for public safety is that you have to get public safety buy-in. So we actually test with public safety users, right? We bring them into our lab. They're our test subjects, and we work with them to do this research. But the problem is you have these two worlds that don't work well together. You have a laboratory environment that's pristine, it's clean, it doesn't look anything like the world in which they would work in. And we bring them in and we give them some kind of heads-up display and say, hey, do you like the way the map's displayed in the field of view? They go, yeah, it looks cool, but I don't know how it's going to work when I'm in the fire. Well, we can't take that device out and put it in a fire because we can't. Our lawyers won't let us. We can't repeat it. We can't control it. So it's not a place that we can do experiments in. So what we've started to do is we have taken virtual reality and are using VR to recreate realistic public safety scenarios, provide tasks to be performed inside of those scenarios, and then we can envision whatever user interface we want to within that world to see which one will actually allow them to perform that task better. And we can start to measure the impact of those capabilities in the world of VR, and then determine what things should be placed into AR or heads-up display when those technologies become viable for that use. They're not yet, but when they do, we will know what to put on, how to use it, how it will use it in the public safety world. And we're doing this with commercial off-the-shelf equipment. This is not multi-million-dollar equipment. This is an HTC Vive and a high-end computer. So it's hopefully things people can take our work and do it in their own laboratories very easily in academia and industry as well. So what I'm going to show you real quick is an example of we held a prize challenge in June in which we developed a very simplistic, complex building floor map and had some fire and smoke. And the contest was for people to develop heads-up displays that would help a responder navigate through that building from point A to point B and back out in the fastest time possible. And there would be explosions along the way. They'd have to reroute, so they had to have the right engine to be able to reroute and get to the point and then extract. And we had 3 winners. We had 2 first-place prize winners. We had a third-place prize winner. The third-place prize winner was actually Jason Gerald, that you'll hear from tomorrow. Jason's won 2 of our prize challenges and 1 of our grants, so he's well-versed in, I guess, how to get our money. But these are the top 3 winners, and they're the way they thought of a heads-up display for navigation for public safety. So this one was one of the first place winners, and you saw him tap assist. And what it did, this is a very simplistic interface. All it did is put a line down on the ground that would be like an augmented reality to show where they were supposed to go to get to where they need to get to. Shows a temperature on the right, their oxygen level on the left, and a simplistic location finder on the top. This is the other first place winner. They had a few extra capabilities that were tied to like the risk, information that would be available, a map on the bottom right. But they also really relied on that line on the ground, and they would just track and follow instead of worrying about a map. And then this is Jason's implementation, and they had very similar arrows on the. But in this one, you can actually see where the victim is, and they had that pinpointed in the heads-up display and a handheld map on the wrist. And so the whole purpose of this was really to test out, could this help us determine which interfaces made a difference in that task? And it did. We had people come up with what most people thought the answer would be, which was we had some people have a map actually in the top right corner of the visor. And we found real quick that as you're trying to navigate a building like that, looking up to the far right as you're walking around, you're not paying any attention at all of what you're doing, and you're in a fire. So that's not possible. So the idea that most people thought is, hey, just give me a map. That is actually the worst case scenario. That had the worst outcome of any of the test results. So so that was really interesting. And so the next one we're doing haptics. How could haptics help you navigate through a situation like that? And then the next one will be audio cues and voice commands. what we're working on right now in our laboratory is taking some of those ideas for a heads-up display and actually putting them into our augmented reality headsets. We've got both the HoloLens and the Magic Leap, and we're going to start putting these heads-up displays in that so that we can actually start using them in real environments in our buildings to test and to be able to show public safety. So what are some of the challenges? You guys know the technical challenges better than me. I'm just going to lay out some of the challenges that I see before public safety would ever adopt any of this kind of technology. One is obviously the field of view. Everybody knows the field of view is an issue. I'm a geek, I'm a consumer, I love VR, I love AR. The field of view, I put on the Magic Leap, I think it's awesome, I think it's great, I think it looks neat, but at the same time, if I was really going to use it, the field of view would kind of start to get on my nerves. If I'm a public safety user, it's not even a possibility. They have that needs to be able to take over their entire screen, their mask, their sunglasses, whatever that interface is going to be. There can't be a field of view restriction. The other thing is the input device. For HoloLens, it's gestures. For Magic Leap, it's a handheld unit. For public safety, it's going to have to be a really well thought out input device, because if they're a firefighter, they have their hands full with axe, or they're crawling around on the ground. If they're a SWAT team member, they're holding a gun. They're not able to use a handheld device. They're not able to do a whole lot of hand gestures, and they don't want to make a mistake with the wrong hand gesture either. So that really needs to be thought out. And then the third thing I'll say is public safety is going to be resistant. And now I know that movie earlier was kind of tongue-in-cheek, right? But there is a tendency for technologists to put everything they can put on a screen. For public safety, it's going to be, the art is going to be to put as little on the screen as possible and yet get the job done. So they're going to want to see the real world as the real world, and only the amount of augmented world necessary for them to achieve that task. And it really, to me, that's going to be an art form that I'm excited to see how people innovate and come up with that way to perform those capabilities. Just a real quick. This is currently a map of who's working on these issues for us through our funds as of today. Over 150 entities have received funding through this program, and this is just the beginning. We're going to continue to do this over the next 4 years. So we have worldwide researchers working in this area. This is just a kind of a NASCAR slide of some of those researchers and institutions. So we have a very significant wealth of experts working in this area. We're always looking for more. So if you're one of those that in this area that you think from this, you think you have something applicable, we would love to talk to you. And there's going to be many, many more funding opportunities. And we are a very open program. If you're ever in Boulder, it's an awful place to go, but if you're ever in Boulder, Colorado, please don't hesitate to stop by. We'll give you a tour. We'll show you what we're working on. We'll put you in the systems. We are going to be at CES in January in the technology hall. So we actually don't go to the government hall. We go in the technology hall because that's who we want to get involved in our work. So we'll be at the Sands Expo Center on the top floor. And then we also have an annual stakeholder meeting. About 500 people from industry, academia, and public safety come together, and we go through all of our research. Over this year, it's going to be in Chicago for a period of 3 days. And it really is. It's focused on all the outputs from our research. So it's a lot of information from a lot of different people that you saw up there. It's all there. It's also all online. We taped this year's all online. So if you actually wanted to go and see what we're doing in any of these areas, you could watch 70 hours. You should do it. You should watch 70 hours of material. I haven't even watched it all. 70 hours material with all of the work that we're doing. So please don't hesitate to go online and see that. Otherwise, I appreciate your time. I appreciate your patience. I know you're hungry. I'd love to talk to you. I'm going to be here for the next 2 days. I've already been excited about what I've heard today. I'm looking forward to what I hear over the next 2 days. And I thank you very much.
Before you go,
Yes.
wait, John has a comment. What about him about the conference? Oh, really?
No, I
stay here because you're kind of my poster child, actually.
Oh, no.
I just want to point out that we've all spent a morning here, and that's a morning we could have spent somewhere else doing something else, but we spent it here, and I'm very jealous about my time. And so I have a very simple criteria. What did I learn? And I think I learned a lot of stuff. I certainly learned a lot from you, sir.
Well,
I
thank
had no idea what you were doing. So
I don't know what I'm doing.
I want to congratulate Neil for being able to assemble all the people he did and allow me to learn something.
Thank you very much.
Congratulations.